Let's discuss raising and lowering of operators. Keeping in mind equation A, which is the Hamiltonian of the harmonic oscillator, we define two operators A and A dagger. In some texts, A is written as A minus, a minus sign here, and this is written as A plus, which looks almost same as A dagger. But the definition and functioning of these operators are same, exactly same. These are not Hermitian operators. These A and A dagger, these are not Hermitian operators because they do not correspond to any dynamical variable, and we do not have any classical mechanical analogy for A and A dagger both. Now we need to find some relations. For that we need to do some algebra. Let's find the product of A and A dagger. I have just used the definitions of A and A dagger, and in this line here, coming from here to here, I have used the uncertainty relation, which is a canonical commutation relation, and I found that A dagger looks like this after some algebraic steps. These are quite simple and obvious. I get equation B, where I have substituted for the Hamiltonian itself. In equation C, I have a similar relation, but this time it's A dagger A. Equation B is the product of A and A dagger. Equation C is product of A dagger and A. These operators do not commute, so ordering of the operators are extremely important, and this is quite evident from these two relations. If A and A dagger commute, then A dagger and A dagger A will have similar expression, but here we can see that in the equation B we have a plus sign before half, and in equation C we have a minus sign before half. Let's find out the summation of A dagger and A dagger A, which is nothing but 2 Hamiltonian by h cross omega. If I make A dagger minus A dagger A, I will get 1. This means that these operators anti-commute. Now starting with the Hamiltonian again, which is a summation of kinetic energy and potential energy, I have used equation B, and I obtained H equal to h cross omega A dagger minus half, and from equation C I got this. Again, using this anti-commutation relation, here I have obtained the same relation for the Hamiltonian. What we have obtained here is using simply equation B, but in this step I have used equation C and anti-commutation relation of A and A dagger. Now adding B and C, I get equation number D. These are the relations which we will be using very frequently. Now we need to derive some more relations. As we have obtained the Hamiltonian for the harmonic oscillator as equation D, for the time independent Schrödinger equation, which is H psi equal to E psi, I have written this time independent Schrödinger equation in terms of A and A dagger, and I obtained this equation, which is half h cross omega A dagger plus A dagger A psi equal to E psi. I have just shuffled the terms and I got equation E and F, because I need these forms also in near future. Let's make a very crucial proof. What is that? First, I would like to make a statement. I'd like to say that when A dagger operates on the eigenstate, energy value increased by an amount h cross omega, which means A dagger raises the energy value. If A dagger is applied twice on the state, then the energy value increases by an amount 2h cross omega. And if A dagger is applied n times, then the energy value increased by an amount nh cross omega, and the final energy value will be E plus nh cross omega after n times of application of A dagger. Let's start with left hand side, which is A dagger psi. This is a state and Hamiltonian is already there. I have just substituted the expression of the Hamiltonian, which is my equation F, here. And now I need to do some algebra. This is my starting point. Now I am multiplying A dagger from right hand side. One thing, I need to maintain the order of operation, as these are operators and A dagger do not commute. So after this, I am taking A dagger common. This A dagger is from the right hand side, and I am taking this left hand side A dagger out of this parenthesis. So inside the parenthesis I have A dagger plus half, because this term contains only one A dagger. Psi is there already. Now I am using the anti-commutation relation of A and A dagger, which gives me in this place A dagger A plus 1 plus half. I have taken this A dagger at the leftmost portion outside the parenthesis. H cross omega is just a number, so I can easily shuffle the order between A dagger and H cross omega. That is okay. Now if I multiply this H cross omega inside, I will get 1 H cross omega for this one. I have separated it from this thing because I need to substitute for this term with the Hamiltonian itself. So I have A dagger, the Hamiltonian itself plus H cross omega, and psi is there. And it can be written like H psi plus H cross omega psi. H psi is nothing but E psi. H cross omega psi is H cross omega psi. So here we can write this as this E is constant, H cross omega is constant. So I can insert anywhere A dagger. I can insert A dagger anywhere within this parenthesis. I can write this A dagger here, and I am left with this number in the left side. So I have E plus H cross omega, then A dagger psi. So I've started with H A dagger psi. I ended up at E plus H cross omega A dagger psi, which means this A dagger psi state has a new eigenvalue E plus H cross omega. So here is equation G, which states that the state A dagger psi has an eigenvalue E plus H cross omega, which is greater than the eigenvalue of H psi equal to E psi equation by an amount H cross omega. Similarly, A psi will have the eigenvalue E minus H cross omega, I will show that. So let's start with HA psi. Substitute the Hamiltonian for H cross omega A dagger minus half. This is equation E. So this is how I insert A from right hand side. Similarly, I am taking this A, this one, out of the parenthesis. Again I am using the anti-commutation relation of A and A dagger. Then I am doing some algebra like before. And finally I have arrived at this situation. So H psi equal to E psi, because this is my time independent Schrodinger equation. H cross omega psi is already there here. So I get, after arranging this, I get E minus H cross omega A psi. As E and H cross omega are numbers, are scalar quantities, so I can shuffle this A operator between E and H cross omega. Here the ordering of operator and this scalar quantities, these numbers, are not important. So finally I have arrived at equation H, which tells me that A psi is a state which has eigenvalue E minus H cross omega, that is H cross omega amount less than H psi equal to E psi equation. So in psi we get eigenvalue E, but in A psi we get eigenvalue E minus H cross omega. So these are the actions of A dagger and A operator, which are acting as tools to generate new solutions, and those new solutions will give me higher and lower energy values respectively. That's why A dagger A are called ladder operators. A dagger is called raising operator because it increases the energy values. A or A minus is called lowering operator because this is A. Some texts it is also written as A minus. So A or A minus lowers the energy values, hence this is called lowering operator. Suppose this is my ladder and I am staying right here now. I am standing on this state. If I apply A dagger operator, I will raise one step further. If I apply A operator, I will go down by one step. These are the actions of the A dagger and A operator. Now can we apply A operator as much as we can? The answer is no, because uncertainty have restricted us to get zero energy value. The minimum energy value should be E equal to half H cross omega. I cannot go below that. So here is my ground state, the lowest state, which I call psi 0, correspond to ground state energy eigenvalue E0. And if I apply A on psi 0, my ground state, that is state of minimum energy, I will get 0. What is the physical significance of equation I? Equation I states that I cannot apply A anymore. I need to stop here.